Given f of x equals 1/2 times the quantity x plus 3 times the quantity x plus 1 times the square of x minus 1, we want to determine the degree, left and right hand behavior, determine whether the degree is odd or even, the y-intercept, the number of turning points, as well as the zeros and their multiplicity. Let's begin by determining the zeros, which are the x values for which the function value equals 0. Notice x plus 3 is equal to 0 when x equals negative 3. X equals negative 3 is a 0, and because we have one factor of x plus 3, the multiplicity is 1. X plus 1 equals 0 when x equals negative 1. X equals negative 1 is a 0, and again the multiplicity is 1 because we have one factor of x plus 1. X minus 1 equals 0 when x equals 1. X equals 1 is a 0, but because we have two factors of x minus 1, the multiplicity is 2. The zeros of a polynomial function are also the x-intercepts of the graph. Let's go ahead and plot these as x-intercepts. We have negative 3, 0, negative 1, 0, and 1, 0. The degree of the polynomial is the sum of the multiplicities, which we could see as 1 plus 1 plus 2 or 4. And 4 is even, so for part D we circle even. We could have also determined the degree by thinking about multiplying out the function rule. Notice we'd have an x to the 4th term, and the leading coefficient would be 1/2, which means if we expanded f of x, we would have f of x equals 1/2 times x to the 4th plus several additional terms, but we can use this leading term to determine the end behavior. Because the degree is even and the leading coefficient is positive, the graph will go up to the left as well as up to the right, if needed. Here are the notes on the end behavior based upon whether the degree of the polynomial is odd or even, as well as whether the leading coefficient is positive or negative. Let's go ahead and determine the left-hand behavior, which is as x approaches negative infinity, f of x or y approaches positive infinity, because as we move to the left, the graph goes up, and again, y or f of x increases without bound and approaches positive infinity. The right-hand behavior is as x approaches positive infinity, again, as we move to the right, the graph goes up, and therefore y or f of x approaches positive infinity. And now let's determine the y-intercept. The y-intercept is where the graph intersects the y-axis. Every point on the y-axis has an x value of 0. To determine the y-intercept, we determine f of 0. F of 0 equals 1/2 times 3 times 1 times the square of negative 1, which is 3/2. The y-intercept is 0, 3/2. If we want 0, 1.5. Let's go ahead and plot this. For the last part, we want to determine the number of turning points the polynomial has. A turning point is where the polynomial changes from increasing to decreasing or decreasing to increasing. An n-degree polynomial can have at most n minus 1 turns. In our case, we can have at most 4 minus 1 or 3 turns. Let's make a rough sketch of the polynomial based upon what we know about the polynomial function. Recall, if a 0 has multiplicity 1, then the graph will pass through the x-axis at that location, and if the multiplicity is even, the graph will touch the x-axis and bounce back at that location, or we can say is tangent at that location. So because the multiplicity of negative 3 is 1, the graph will cut through the x-intercept negative 3, 0. At some point, the graph will have to churn to reach the next x-intercept of negative 1, 0. The 0 of negative 1 has the multiplicity 1, and therefore, again, the graph has to cut through the x-axis at x equals negative 1. At some point, it has to churn to pass through the y-intercept, let's just say here, and then the 0 of positive 1 has multiplicity 2, so the graph is going to touch at x equals 1 and then bounce back. From here, we know the graph goes up. Analyzing the graph, the function is decreasing, increasing, decreasing, and increasing. So we do have the most turning points possible. We have 1, 2, 3 turning points. And of course, we can graph the polynomial function on a graphing calculator, and this does verify our work is correct. I hope you found this helpful.